All right, guys, in this lesson, we're going to be talking about factoring differences of squares. What do I mean by factoring differences of squares? First of all, factoring is, say, for instance, if you have two numbers multiplied by each other, say 6 times 7 is 42, the 6 and the 7 are factors of the product 42. And when I'm mentioning squares, we're talking about, say, x squared, or 5 squared, which is 25, or 7 squared, which is 49. So we're going to put that all together in this lesson, and I'm going to show you how to factor differences of squares. Let's get started. So our first problem is x squared minus 9. So let's work our way backwards so you can get an understanding of what the answer is going to be, and then we'll move forward. So I'll move off to the side here and say, let's take x plus 2, x minus 2. So we know when we're multiplying binomials, we'll use our FOIL method, which is first, outside, inside, last. So when we're looking at these two binomials, our first variables are x and x, so we have x squared. Our inside is 2 and x, so we have 2 times x is 2x. Our outside is x and minus 2, so minus 2 times x is minus 2x. And then our last numbers are 2 times a negative 2, which is negative 4. So as we can see here, we have x squared, and then we have 2x minus 2x, so this cancels out. So we're just left with x squared minus 4. Another way you could write this is x squared minus 2 squared. So you can see you're left with just squares, the x squared and the 2 squared. So you could look at this pattern as x plus a number, x minus the same number will cancel out the x variables. It will leave the x squared and leave whatever's on the end, which will also be squared. In this case, it's 2 squared, which is 4. So hopefully that makes sense. So now we could go back and look at x squared minus 9. Well, based off of this previous example, we automatically know, using our FOIL method, that the answer is going to be x plus 3, x minus 3. So first we'll have x times x, which is x squared. Then we'll have our outside, x times negative 3, which is negative 3x. Then we'll have our inside, which is plus 3x, 3 times x. And then we'll have our last, which is 3 times negative 3 minus 9. So when we combine like terms, we have x squared minus 3x plus 3x, that goes away, and we're just left with x squared minus 9. So you can see a pattern here. You see how that works. We could also write this as x squared minus 3 squared. Here we have our squares. When we factor our differences of squares, it is usually taking the factor, and you'll have a plus and a minus, and there you have it. So hope this helps. We'll move on to the next problem. Our next problem is n squared minus 25. We could also write that as n squared minus 5 squared. So going back to our previous example, we know when we're factoring differences of squares, this is pretty much going to be n plus 5, n minus 5. And we could go back and check it using the FOIL method. Our first variables are n times n, which is n squared. Our outside variables is minus 5 times n, which is minus 5n. Our inside variables are 5 times n, which is a positive 5n. And then our last numbers are 5 times a negative 5, which is minus 25. That leaves us with n squared. The minus 5n and plus 5n cancel out, and we have n squared minus 25. giving us our original problem, which can also be written as n squared minus 5 squared. All right, let's try one more problem just to make sure you get it. Our last problem is 36x squared minus 49y squared. As you can see, in situations like this, I'm already trying to look for factors of numbers that are multiplied by themselves. So as you can see here, 36 would be 6 times 6, and 49 would be 7 times 7. So we automatically know that the factors for 36x squared minus 49y squared are 6x plus 7y, and then 6x minus 7y. And the reason we know this is once we use our FOIL method, we'll be multiplying 6x times 6x, which will give us a 36x squared. We know that the values in the middle will cancel each other out. And then the last value will be 7y minus 7y, which will be minus 49y squared. So let's go ahead and do that. So using the FOIL method, our first variables are 6x times 6x, which is 36x squared. Our outside variables are 6x times 7y. That's going to be negative 42xy. Then our inside variables are 7y times 6x, which is going to be a positive 42xy. And then our last variables are 7y times 7y, which is negative 49y squared. Minus 42xy plus 42xy cancels out. We knew that that was going to happen, and we're left with 36x squared minus 49y squared. So this lets us know that our factors are truly 6x plus 7y and 6x minus 7y. So I wanted to be able to show you how and why it worked. This could also be written as 6x in parentheses squared minus 7y in parentheses squared. All right, so I hope this helps. If this helped you, send it to someone else. We're talking about factoring differences of squares and how that middle information usually cancels itself out. And so we'll look at other factoring differences of squares in the next video, and we'll see you soon.